Hello everyone. I will start this lesson with a quick prediction. I'm defining a person in here who's 25 years old, bachelor degree, studied for 14 years, works 40 hours a week, never married, from the United States, works in sales, white, not in family, is a male and works in private sector. This is based on data from 1994, so this might not reflect the marketplace today, but I will try to make a prediction whether he makes more or less than $50,000 a year. It tells us that he makes less than $50,000 a year. Let's look at the same guy 10 years later, when he was 35. He still works the same 40 hours, bachelor degree, same occupation, same everything. Let's see what happens in 10 years. Now he makes more than $50,000 a year. If we changed the race, his race to black, we can see that he makes less than $50,000 a year. What if he was working 45 hours a week? Now he makes more than $50,000 a year. What if that was a female? Makes less than $50,000 a year. Let's try to make that 50 hours. Still less than 50,000. Let's make that 55 hours a week. Now she can make more than $50,000. This might look like a very bad results, or it might not sound like good results to everyone, but this is just based on census data from 1994. This is lesson 2 of machine learning series, and it's an introduction to machine learning. If you have not seen part 1, we discuss Python, IPython notebooks, Matplotlib, NumPy, Pandas, and Amazon Web Services. In this lesson, we'll be replicating the results that we have just seen in our quick prediction system. Machine learning uses regression, clustering, and classification as basic tools to emulate learning and do predictions. Let's go to Amazon Web Services, and let's go to our management console. You can go to Amazon Web Services, aws.amazon.com. If you don't have an account, open one, it's free. And everything that we will be using this lesson will be free. So you can replicate everything we do without paying anything to Amazon Web Services. We'll be using services from the free tier for the purposes of this lesson. Let's go to EC2, the service that we will be using. We will launch a new instance. Choose your AMI from community AMIs. Look for the one I left public. It's called IPython Notebook Server. Actually, you can just go with IPython, and hopefully you won't find anything besides my public AMI. Select that. And that's taking a little bit to load. That's taking more than usual to load, actually. Let's go. Oh gosh. Okay, select again. Choose the micro instance. This is within the free tier. You can choose something bigger if you want. That will make your system a little faster. Next, we can just go to review and launch. Once you're in review and launch, go down to security groups, edit security groups, and open the extra 2 ports that we need to manage the system, 8080 and 8000. Review and launch, then click launch. If you don't have a key, create a new one and save it somewhere safe. I will use the key I already created before. It's launching my instance now. You can see that I have tried to record this lesson earlier, that did not go well. So the first thing we do, we name our instance. I will just call it lesson 02 so I can tell it from the other one. And it's initializing now. We can access it from the public IP, so we'll copy the public IP and we will go to it, colon 8080. That will take us to IPython notebook server. Once we're there, we'll put the password. The default password is Roshan, Roshan, Roshan. Go to lesson 2, Introduction to Machine Learning. This might take a few seconds to load. It's big notebook. So in this lesson we'll learn about Scikit-Learn. We'll learn how to choose which type of algorithm to use, and we'll learn about some public datasets that you can use to experiment and learn with. Then we will be replicating the classification example that we have seen in the beginning of this lesson. One important tool that we always need is Agenti. It's our administration interface. We will open this link and we will paste our IP in the place of the word IP. It will tell us that it's not a signed certificate. That's okay. Or not verified certificate because it's self-signed. Username and password. The username is root and the password is admin, admin. Don't want it to remember. Thank you. Thank you. Okay, we will be using this tool mainly to monitor our memory usage during this lesson. So we want to keep an eye on memory usage. We want to make sure we don't go beyond our memory. If we exceeded the memory, we'll start using swap, and that would be a very big no-no in any machine learning application. You always want to use only memory. So let's go back to the lesson. Scikit-Learn. Scikit-Learn, it's a machine learning library written in Python. It's simple, efficient, it has tools for data mining and data analysis. Machine learning uses 3 types of algorithms depending on the problem that you have in hand. We have clustering. Clustering is used to group data into groups according to their similarities. So in here we had black dots all over the place, and a clustering algorithm predicted that these orange points belong to one group, red points belong to another group, and red and green points to and the green points belong to a third one. It could not cluster the rest of those black dots on the screen. Classification. In here we have black data points and white data points. And the algorithm made a decision function that will tell if a new data point will be considered black or white without knowing if it's black or white, just depending on where does it fall on this chart. So if it came anywhere in here, it's a black data point. Anywhere in here, it will be a white data point. That's another way to do the same problem, to classify the same problem with different weights for the algorithm. The third thing that we'll be dealing with is regression. In here we have a few data points, the red data points. The algorithm will try to fit a line that goes through them, and it will predict where does it think this might go, and it will show you according to the algorithm that you're using an area of confidence. So this is an area of confidence that it might proceed to anything within this area. This is a little chart that shows us which algorithm to use. It doesn't have every algorithm in Scikit-Learn, but it's a very good place to start if you don't know which algorithm to use. So it will ask you first, do you have more than 50 samples? No. Go get more data. If you're predicting a category or a quantity, if you're just looking at data, if it's labeled data or not, it will lead you to some algorithm that you can use, if it's text data or not, and it will help you choose an algorithm. Again, it doesn't have every algorithm in the system, but it's a very good place to start. Datasets. You need datasets to work with the machine learning. These are some datasets to get you started. This is an archive. It's a public archive for machine learning, and this is the Scikit-Learn datasets that's public. Inside each dataset, you will find samples which represent records. So if a data sample is about people, each sample will be one person, and it will have features or attributes, and those features represent a feature about that person. It might be age, it might be income, or something else. So let's examine some data. We will be working with this dataset from UCI, and this dataset is 48,000 records, more than 48,000 records. It has 14 attributes. Here is some information about it. These are papers that cited this dataset. You can see a very long list of papers that cited this dataset. And we can go to data folder, and in here we will see the file that has the actual data. This is the file that has the actual data that we'll be dealing with, and we can either download this file into our machine and upload it through Agenti to our data folder, or we can fetch it directly over the internet. So let's go back to our lesson. This data, I copied the description of each column in the dataset. This is a small sample of the dataset. So you can see, for example, this person is 39 years old, works for state government. This is his weighted demographic number. Bachelor degree, studied for 13 years, never married. admin clerical, not in family, white male. This is capital gain, capital loss, works for 40 hours a week. From the United States, he makes less than $50,000 a year. So, we will start to build that example that we have just seen, the predictive model for classification that classifies if people make more or less than $50,000. So we will execute the first code cell to import our libraries. To execute any cell, any code cell, click in the cell and hit shift and enter. And once you see the number appears in here, this means it finished processing this data cell. Second thing we will do, we will load data. So we can fetch it directly from the URL or use the path for this file. You can upload the file, download it to your system, and upload it to the data folder and using Agenti. And here I just named the columns because in the dataset it doesn't mention the columns, the column names within the dataset. So I have the column names in here, and I'm using pandas to read comma separated value. This is a method that reads comma separated value files. To know how does this method work or works, you can go inside the method and hit shift tab, and this will show us this little interesting hit it again. It will show us this little interesting help box. We can expand it and see these are all parameters that you can pass to read comma separated value, and it will help you read the file in the right format. So we'll be fetching it directly from the URL. Second thing we notice about file, the separator is not just comma, it's comma then space. So we will use the parameter for separator to do that. I'll pause the video and I will be back. The second parameter is names. In here we pass a list with column names for the comma separated value file, because this comma separated value file doesn't come with headers in the file. The last parameter we're using is in rows, which is number of rows. We're limiting that to 20,000 because of the limited amount of memory we have in our instance. So let's run that. Again, to execute, shift and enter. We will do some statistical analysis of our numerical features. We have age between 18 and 90. This is a weighted identifier of demographic or something like this. I read the description. I couldn't get exactly what does it do. Education numbers, the number of years people studied. So around 50% is 10 years. Capital gain, almost no one made any money. And capital loss, almost no one lost any money. Hours per week, this is how many hours per week people work. And we can see very clearly that almost everyone is working around 40 to 45 hours a week. So this is how we can describe our data. Always remember that your data is stored in this variable, CSV underscore data. Visual inspection. This is a scatter matrix of all the features. I pre-executed this code cell so you don't have to do that. It will take a few minutes if you try to do it again. So I executed that before I started this lesson, and in your instance you will find the executed version with the chart. This chart basically um, um, lists all numerical features: age, weighted demographic, education number, capital gain, capital loss, and hours per week. Uh, and it plots all of that, or scatters all of that against the same features. And whenever the feature is scattered against itself, so hours per week, with hours per week, it gives a histogram of that feature. So we can very clearly tell that everyone works 40 hours a week. There is a little bump around 50 and a smaller one around 60. Um, Capital gain and loss, we can see that it's there is no data there because almost everyone made 0. Um, this is education number, so how many years people studied. We can tell that almost everyone studied 9 years, then 10. Those are the highest values. Then we have a little bump around here, which is 13 years. So 13 years, 14, 15, and 16 finally in here. I don't understand this feature, so I wouldn't try to explain it. This is age. This is just a histogram of age. We can tell that almost everyone is in this range, and it drops rapidly after that, which is around 45 years of age. Um, so we will visualize some data. We will scatter again to get the little help box for any method, like scatter method. We hit shift and tab, and we get this help box or help window. We can see that we should pass an X and Y. Then we can put colors there, markers, color map. There are a lot of features that we'll be using. Alpha, we'll be using that too. This is transparency level for colors, so we'll be using that too. So we're scattering X, which is the education number, which is how many years did someone study, against age. So our Y will be age, and our X will be number of education years. And here we're doing a little filter. So whenever we want to filter our data, we pass one of our columns. So we pass income and equals to any value, which is more than 50K. That will filter only people with more than 50,000 annual income. We're using alpha of 2%, so it's only showing 2% of the color, which is 98% transparent. We're putting a label there so we can identify it, and using red color for people with higher than 50,000. We're doing the same thing for people with income less than 50,000, and we're scattering them in blue color. We're showing legend and final method, which shows actually the chart. And this is our chart. We can tell that more people who studied like 16 years are most probably will be making money since the beginning of their career. People with 15 years around the same time, but maybe a little later. People around 14 years. Well, there is still a very high chance that they would be making more than 50,000. 13 years around their end of their career, they would most probably be making more than that. We can tell that there aren't much people who studied 11 or 12 years. 10 and 9, uh, we can see that people who stayed until they're, well, around 60 when they actually made more than 50,000. And we can tell that almost no one before that time is making good money, but there aren't much people in that bracket anyway. We can see the faint colors which tell us the density of people in here. The problem with this chart, everything is scattered on one line because no one studied like 9.5 years or 9.3 or 9.1 or 8.9. So everything is scattered on one line. So to take care of that, we add a random value of minus 0.5 to 0.5, which scatters this line within a range, and it never goes to the next range because it scatters only between minus 5 and plus 5. So to do that, we add numpy random uniform minus 5 to minus 0.5 to plus 0.5, and we will generate an array that's similar in length to our dataset. So we're getting the length of our dataset and passing that as a parameter, so it will generate a random list of numbers between minus 0.5 to 0.5, and the length of that array will be or list will be the length of our data. And we're adding that to education num, which is the number of years they studied, and we're storing the result of that in education num underscore rnd for random to differentiate this feature. We're plotting on a bigger chart that's 12 by 8. That's a big chart. We're doing basically the same thing in here and in here, but we're changing the alpha value to 10%, so points will be more clear. In here we can see in the legend we can barely see anything. If you don't have very good contrast in your screen, you won't be even seeing the faintest dots because it's 98% transparent. In here it will be 90% transparent, so it will be fairly visible. After that, I'm adjusting x-axis and y-axis by adding labels to them and adjusting text and limit. And finally, I'm putting a grid and title on the chart. And after that, I'm dropping the feature that we calculated with the random number. So we get back to our original dataset. Let's plot this and see what we get. That might take a few seconds to process because it's a big chart. And we can see way more information than our original chart. We can see the trend in here, where the more people spend in studying, the later they enter the market, where we see people entering the market around their 30s who studied around 16 years. We can see a little a dense area in here, which shows that some people are actually working part-time at a very young age, around let's say 18 or 17. And we can see this very large blue area, which is around 9 years, where almost no one is making more than 50,000. 10 years, people above 50 they do have a good chance of making more than 50,000. There isn't much people in this area. We can clearly see that now. And we can see a dense area around 13 years, where more people are making more than 50,000 after a few years of their career. After almost less than 10 years of their career, they have a good chance of making more than 50,000. 14, 15, and 16, we can see it getting redder and redder, and the threshold for where they can start making more than 50,000 is down to the beginning of their career. Basically, we can see the dense area going like this almost, where this area is the high income area of our chart. Processing text features. You can process text features to convert them to numbers, and this is what we or binary, like 0 and 1, which are still numbers, but you need to process your text features and convert them to numbers somehow to make them machine learning compatible. The way to do that, you can vectorize your data, which says, for example, if you have three people, if you have three cities like London, New York, and Toronto, and this would be their your user's location, you can vectorize those features to a feature with true or false, and it just says, for example, he lives in London. So if someone lives in London, they will have one there, and a second feature will be lives in New York. A third feature will be lives in Toronto. For someone who lives in London, he will get for the first feature 1, 0 for second feature, and 0 for the third feature. If you have another way is to convert it to series of number representing their original value. So sometimes you'll get results like excellent, good, average, bad, terrible. You can easily convert that to 5, 4, 3, 2, 1, which would still keep the original meaning of data. With the text document, use count vectorizer. It's a way to process big documents, big text documents. We will go through that in a later lesson. And finally, have special values. Sometimes you have emails, URL, phone number, username. You have to process some of those with special treatment. For example, for a URL, you want to fetch that page and process the content of that page using text processing, but you still want to see if there is an image there. It might be a link to an image. It might be a link to a social media page where you want to know who owns that page and store that information to. And so depending on what do you want to do with the data, you might need to do special treatment for those special values. We will proceed with this data now. We'll vectorize our data, but we will the first thing we will do, we will drop in A, which drops not available records. So and record with nulls or blank data, it will be dropped. Then it's dropping few columns: capital gain, capital loss, income because it's the result that we want to predict, and the weighted demographic. And we're dropping those three features because they are not machine learning useful to us, because there is almost no data on those two, and this one is it has a very large range, and I'm not really sure that it represents anything that can be related to the result that we want to calculate. Finally, I'm converting that to a dict, which is a dictionary, and the output type is records. So it will create a list of dictionaries. Each dictionary has all the values in a single record. And finally, it's converting that to an array. I'm adding an extra column sorry, I'm adding a new value called results, and it equals to comma separated value of income, which is this column of comma separated value data, equals more than 50k. So it will compare more than 50k to each value in here, and if it's equal to it, it will return true. If it's not, it will return false, and it will store this list of true and false results in a variable called results. Um, um, Actually, now we split data into a training and testing set. So we have 20,000 records. We will be training with all our records except the first for the first 1,000. So we go 1,000 colon, and if you leave that empty, it will use the rest of that list for features, which is the vectorized features from our comma separated value data. Second, we have results, and we're getting all the results except the first 1,000. For our test data, we're using the first 1,000, so we go empty colon 1,000, so it will start from the beginning and stops at 1,000, and the same thing with results. Let's see just one of the records, just to visualize that and understand how does it look. It's a dictionary with all the features inside it, and that is what's passed to the vectorizer that converts all those text or string features into numbers, basically, into binary numbers. We'll train a classification model using KNN. Instead of trying to learn what does this algorithm do exactly, it's much better just to see the results, learn other algorithms, and try to basically develop experience in choosing the right algorithm with time. It's oh, sorry, we did not process this one yet. We should execute this one first, then we go back to this one and execute it. So we have a variable called KNN now that has a non-neighbor classifier, and it's fitted with the X training and Y training sets, which is the complete data set except the first 1,000 records. Now we want to do a prediction, so we'll predict our X test, then compare our prediction to Y test, and that would be our accuracy. So let's test that. Finally, I'm printing just the first 10 predictions, and I'm printing the prediction itself, and I'm printing the prediction equals the actual data, so it will tell us if it's correct prediction or not. So we can visualize at least 10 of the results and see how do they look. And here we have a loop. I promised to explain things as we go. So for counter, that's how we do loops in Python. For counter in range of 10. So that will range of 10 is a method that will create a list that's like this. It will be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and that would be equal to range 10. But instead of doing that, it's much easier to write range 10. So this is done. Our accuracy is 81%. Sample data, it predicted that this guy doesn't make more than 50. That was correct. False, correct, false, correct, false, correct, true, false. It predicted this guy made more than 50,000, but he didn't. This guy made more than 50, but he didn't. and here it predicted he didn't make more than 50 and it was true. It predicted more than 50 and it's true. Less than 50 and it was false. He actually made more than 50. True and it's true, so he prediction is more than 50 and the actual was more than 50. We will see better reports now once we're trying to improve our accuracy. So to improve our accuracy, there are a couple of parameters inside this classifier. One of them is the number of neighbors that it will use, so n neighbors, and the other one is the weights method. So it has two weights method, one called uniform and the other is called distance. And we will be looping over range from 1 to 15, and we will be looping inside of that with uniform and distance. And we are passing the value of the first loop and the value from second loop to the parameter to test different values. So we'll be testing all values from 1 to 15 for n, and we'll be testing all values for uniform and distance for each of those values. So let's run that. That might take a little bit of time to run. So that's the first one, neighbors 1, weight uniform, precision, recall, F1 score, and support. This is the standard report that we use to test the accuracy of a classifier. Support is the number of samples for each class we have. So the number of samples for less than 50,000 was 768, and for more than 50,000 was 232. So we can see that we have way more people making less than 50,000 in this sample. The total number is 1,000. Precision is one of our metrics for measuring the accuracy of a classifier, and it's showing the precision for each class. Recall is very important. We want to make sure we have high recall values that will ensure high accuracy, because recall is not just getting the correct answer, because recall is calculated by calculating all true positives, which is like correct detections, divided by correct detections plus false negatives, which is values that it missed basically. So this is recall value. We want to make sure we have good recall values. F1 score is another metric. All of them, the highest value for all of them is 1 and the lowest is 0. So we're looking for values higher and closer to 1. This is our first one. It has 79 overall accuracy, but this is the report that we will be looking at from now on. So 1 uniform, good values. We have distance. With 1 it doesn't really matter, but with the more than 1 neighbor, it will start making a difference between uniform and distance weighting methods. And here we can see really low recall value. That's still not really good. We can see that we have so many this is fairly good actually. The results that we have for 5 neighbors is fairly accurate. 81% is a good number. In here, even though it's 83 overall, the actual numbers we have for recall is really bad. So that's not a model that you want to be working with. Well, this one still not really good. That's a good one. That's a good prospect. 7 with the uniform. I think the best one I found was number 11. Yes, this is it. It's 11 neighbors with uniform weights. You can see the rest of the results. You can go through them. You can use a specific one of them to do some testing, some further testing. So we will use this one with 11 and uniform, and we will keep our trained model using those parameter in KNN. Usually want to put the predictions back into the original dataset if you want to save that as a file to send it back to your client or something. So that's how you do that. You just add a new column and you put your predictions in there as a Panda series. And this is the example that we started with in the beginning of this lesson. Let's run that one last time just to see. More than 50,000. These are all the values. You can use those values in here to define different people and see how changes affect their income. This is a little chart I got from Wikipedia that will help you if you did not study in the US to identify how many years do you need to have different levels of education. So this is education number. This is the end of lesson 2. If you have any questions, leave them on this video as a comment or on Twitter or Google+. Thank you for watching, and hope to see you next time.